Hello everybody, my name's Erik. Just to get started, I was wondering if I could get a show of hands, how many people cut code on a reasonably regular basis here? Okay, and please keep your hand up if you cut code that other people end up running, even if it's a web service that people get used via the web or where it's an application or it's open source, whatever. Okay, how many people use more than, okay, so keep your hand up if you use more than one language in a normal week. More than two? More than three? Awesome, okay, so I've got the right audience here. First up, I'd like to make a special thanks to Peter Miller, who I've known for 10 years now. A lot of the ideas that I'll be discussing tonight are things that I've discussed with Peter over the years. I've worked with Peter at 2 different jobs. He's always got some really interesting things to say about this particular subject, which is something that's close to both of our hearts. I want to start with a quick thought experiment. What happens if your web browser crashes? Meh, you start it up again, no big deal, right? What happens if the Facebook server crashes? Well, there's lots of people all around the world going, oh, bum, can't do Farmville. Too bad. What happens if a heart pacemaker crashes? Somebody dies. The person who has the heart pacemaker is likely to die, unless it's under development on the bench top, not a problem. But you know, if it's actually embedded in somebody's chest and it crashes, somebody dies. Sure. This is thought experiments. The software controlling the ailerons and the rudder and stuff on a jet airliner, if that crashes, lots of people die. But I'm going to go back just a little bit because I even think this web browser thing is a problem. Is anybody aware of this recent security advisory against Netscape 3.6? Remote execution of code in your browser. Probably more of a worry for the Windows people, but with people doing things like internet banking in their browser, remote execution of code in your browser where you do your banking, that's one that don't feel real comfortable with. What happens when the Facebook server is broken into? Because basically every time you get these crashes, so just going back to this one, make the actual point real clear. Just about every time something like a browser crashes, because of content it has received from the internet, there is a chance that there is a way to make that browser execute code that is sent from the server. And if that's JavaScript within this JavaScript sandbox, that's fine. If it escapes that sandbox and is running as you on your machine, you need to be worried. Similarly, if the Facebook server gets broken into, there are privacy implications, you know, there might be enough to get your date of birth, and suddenly there's things like what do they call it? When they get your identity. Identity theft, that's the one. Identity theft. Gus knows this sort of stuff.
You looked at someone and it looks just like
What if it's not the Facebook? What if it's the main stock exchange server? And nobody knows, apart from the person who's hacked into it. You can control an economy, a whole economy of a country, if you have control of its stock exchange server. This can have really serious implications. And this is probably one of the ones that Peter Miller brought up really, really early on. If we, as software engineers, don't fix this stupid stuff, governments, if something big and bad enough blows up, and you get a couple of them in a short period of time, governments will license software engineers just like they do doctors. They will restrict what programming languages you use. 10, 20 years ago, the language which was big in governments and military sort of things was ADA. Everybody would be programming in ADA. There's a whole pile of people gritting their teeth here. Now, with Java being so big in the enterprise, I'm pretty sure it's Java. That personally makes me grit my teeth. Yeah. they'd be doing things like mandating design methodologies. You must do UML for every line of code you write. Rational rows. There's a whole pile of these really horrible things out here. So this is where I'm going. So the other thing is that I actually don't believe that free and open source software is significantly better than our competitors at this. I think it's about neck and neck. Yes, IE6 was a crock and was horrible, but IE8 is pretty much neck and neck with Firefox in terms of security vulnerabilities and a whole lot of else. Usability. Exactly. So there's some deeper consequences here, which is why I'm bringing up this stuff. Now, I am known as somebody who likes to have a bit of a rant. I know a couple of people who decided not to show up tonight because they thought I'd be trolling, and I could just as easily have replaced rant there with troll. I'm going to try and avoid that, honestly. So basically what I'm going to do is I'm going to look at some things, why is this thing so hard? What problems do programmers face? Tools and techniques, and the future. Now here's where I break it to you that there's so much stuff here that I can't cover it in 1 month. I'm going to do about half of it this month and half of it next month as the second talk. Tonight's talk will basically be stuff that even people who aren't programmers will be able to follow along and get something out of it. Next week, when I'm talking about tools and techniques, and particularly the future, I think that will be something that most non-programmers, their eyes will glaze over, and they should probably be in the other room next month. But I'll look at this. I'm going to say there's two main reasons that this is so hard, and it comes down to humans. If you believe, like I do, that human beings evolved from apes and monkeys and things, you will know that modern humans first came around in Africa about 200,000 years ago. Around 10,000 years ago, which is the very, very latter bit of it, we started using things that started to look like tools. And we didn't even get the internet until the late 60s or so. So our brains were adapted for surviving on the savannah, where it's a matter of killing our food, avoiding lions, doing a whole pile of things that take short attention spans. In fact, I should have put that slide around there. Whereas that sort of stuff we evolved from is completely different to what we do as programmers. Programmers require intense concentration and attention to detail. And with our evolutionary history, those two don't match up very well. And humans are lazy and easily distracted. Oh, look, shiny. There's a web browser over there. It's got Facebook or whatever. There's a mismatch between the people who do the coding. You missed my slide where I say I'm not trolling. Anyway. There's a mismatch between the task and the person doing the task. And I'm going to talk about that a little bit. The other thing is programmers lose touch with reality. I do it all the time. I'm actually nowhere near as good as I think I am when it comes to code. All programmers do this. And in fact, I'd even say that I have never met a pessimistic programmer.
I disagree with that, because I've done research that you find that a lot of females underjudge this.
Okay, sure. That may well be true. That's a really interesting point.
I always look myself, and I know most of the people that I know.
Yep. I think it's a real pity that there aren't more women in the computing field. I've worked with at least one very, very good one. I'm talking about the programmers I'm meeting all the time. They're guys, and yeah, optimists. I've never met a guy programmer that wasn't a complete optimist. I mean, I actually, it was always my thought that somebody who was naturally of a pessimistic nature and exposed to a couple of years of day-to-day programming, they'd go and do something else. And the other thing is that programmers love the whole power trip thing, you know, that they have, with their code, total control of the machine and the situation. They actually don't, but they like to think that. So there's a whole bunch of problems. The pure complexity of it, which I'll talk about a little bit more, ensuring correctness, maintaining security, resource accounting, poor tools. There's a whole list of them. There's more. I'm not even going to try anything. I'm going to talk about complexity because this is a big deal. Here's the lines of code in the Linux kernel, and oops, if I get my, what am I doing? Laser pointer right in the middle. Started off really tiny. 160k lines of code is reasonably manageable. But now we're getting up here at about 11,000 lines of code for the whole of the Linux kernel. You can't keep, 11 million lines of code. It's really hard to be a master of 11 million lines of code. Linus isn't, and if he isn't, there's no one there. Mozilla's Firefox. It hasn't shown the growth of the Linux kernel, probably because of the driver thing. I would think a lot of what's happening in the Linux kernel is actually driver work. But, you know, Mozilla, 2 million lines of code. That's just C and C++ and header files. That is one hell of a lot of code. So Steve McConnell is a guy who wrote a book called Code Complete back in 1993. At that time, where the language was probably C mostly, he was saying that the industry average was 15 to 50 errors per 1,000 lines of code. 2 million lines of code, do the arithmetic. Because it's the same language, C and C++. That's what they would have been using back then. He was saying, this was a guy who worked for Microsoft, he was saying Microsoft applications, about 10 to 20 defects per 1,000 lines of code. Somebody who was really hotshot back then, this is Steve McConnell's data here, he could get as low as 3 defects per 1,000 lines of code. And for the space shuttle, they actually managed to get it 0 for 500,000 lines of code. Now, I know we're not doing anything like that. Mozilla, they're probably doing better than that. They might even be doing a tenth. So they might be doing something between like 1.5 and 5 errors per 1,000 lines of code. Still a hell of a lot of defects. Metric crapload of defects. Why is that doing that? Very briefly on resource accounting, because I'm constantly getting this that this is a problem with C and C++. And I beg to differ. Lots of times you have got a file descriptor or a socket in an object, and unless you've got code to explicitly close that at the end, it doesn't get closed until the object gets garbage collected. So you do have a resource accounting thing there, a resource accounting issue there, and it's a matter of that's still a problem. That's probably, I don't know, I don't like that slide. My conclusion after looking at this and being an avid user of a bunch of different programming languages is that every single one of them sucks. None of them help programmers, none of them help programmers enough to write bug-free or even, you know, acceptably low bug code. Flying through this. I've got a lot of slides. I'm going to look at a little bit about tools and techniques. And most people have probably met the programmer that uses the language they learnt for everything. I noticed that there's Gtk bindings for PHP. So I've never seen a web server that has a GTK window anywhere. So I'm suspecting they're actually writing desktop applications in PHP to get GTK things. People do some strange things. It's a matter of choosing a language for the task. I want to look at designing for quality because I think there's actually a whole bunch of things that can be done at the design stage that can make it harder to make it possible to write code that is harder to do stupid things with. I'm looking at exploiting particular features of particular languages very quickly, features of compilers, other tools, and then next month go on to processes and type systems. Type systems is a particular hobby horse of mine that I'm very fond of. So with appropriate language, we're talking about things like text processing in C. Anybody who's done this knows how horrible it is. XML parsers written in C, can you imagine it? Just horrifying. The second one, Linux kernel module in Haskell. Yes, somebody has actually done this. You can actually make a pig fly with enough thrust, but I think this is a bad idea. Now, I actually don't think that C is actually all that great a language for writing kernels, but that's a different matter. If there was a Haskell kernel, then kernel modules in Haskell might make sense, but I think there's an impedance mismatch between a Haskell kernel module and a C kernel that doesn't really make sense for. And I hope nobody's done the last one. It really scares me. The idea of a hospital's X-ray machine's control system being written in Python, or any one of a dozen other languages that you can think of. Yeah, you can. Doesn't mean it's a good idea. So with this design for quality thing, the idea is to design code components so they can't be used incorrectly. Wet the old whistle. Now I've got a very simple example here, I think. Really, really simple. We've got two objects, a launchpad door and a rocket, and we want to open the launchpad door and we want to launch the rocket. Really simple, right? But somebody can just do that. Now I guarantee you that if you launch the rocket before you open the launchpad doors, you're going to get a real mess on your hands. And it's just a transposition. Something like this obvious probably wouldn't happen in real code, but I have seen big chunks of code where this happens all the time. But there's a really simple solution to this. If your rocket is a class and you have a launch method, if you pass the launchpad door in as a parameter to the function, you can then at the very top of the function do launchpad door open, and using it as rocket launch with the launchpad, you've got a guarantee of the launchpad door being open before you do the rest of the launch procedure. As long as that line stays at the top, yes. There are languages where you can actually do this, and I might expand on this particular example for next month's presentation, because I think this can actually be fixed in the type system. Jack?
Do you think in this example, now it's not a jump test, this example, you're giving the responsibility of opening the door now to the rocket, where you might consider them to be two independent objects that shouldn't be the manager of the other?
I agree. This is a very simple, naive example.
So the right way to do this really would be to assert that the launchpad door is open rather than actually opening.
Well, I mean, there are some places, basically an assert in your code, an assert basically goes, oops, I've found something wrong here, and crashes. Let's go back to the X-ray machine. That's not a pretty thing either. Well, yes, but so if the assert goes wrong, then you've got error handling, and if the error handling so you've got this error handling code that only gets run under exception conditions, and what happens if there's a bug in that? You can get cascades of bugs. I had a piece of code that I was working on long ago that took 2 hours to run, and there was a bug in an exception handler written in Python. There was a bug in an exception handler that didn't fire, and in fact I found there was a couple of instances of this thing where there was exception handlers that had bugs in the exception handler because a class had changed somewhere, and suddenly in the exception handler where it was supposed to do some cleanup and then continue, it was not. It was going belly up and splat. And so while it might have been running for half an hour of the simulation, it meant that I basically had to go back to fix the bug, go back to the start of the simulation, run it again, and then I ran into another one later in the same program because some class externally had broken.
So I guess in this situation it's a question of, do you want this program to actually run even if the order is the wrong way and just to fix itself? Or do you actually
Next week,
want to, as an operator, be told that, hey, your doors aren't on?
as far as I'm concerned, if it's something as big as this, if it's a hospital X-ray machine, I want it to be found at compile time. Full stop. If it isn't found at compile time, I want to change the program until it is. And I'll be looking at that next month. There really are some answers to this that give you those kind of guarantees. In my day job, I do some C++. There's a wonderful thing called resource acquisition is initialization. People see the blue is comments. The rest should be, is the rest okay? Yeah, they can't see the red either. Okay, so it's void. It's basically the destructor. And what I'm saying here is that in this the destructor for the class object, there we go, lovely. In the destructor for the class object, you release all of the acquired resources. And then in some function here, you've got a chunk of code at the top. Then you open and close. You've got a scope, an internal scope here, just open with parentheses. And for the non-programmers, the semantics in C and C++ are such that you open and close what they call scopes with open and close parentheses. You can access things in the outside scope from inside, but you can't access things that are in an inner scope from the outside. The way this resource acquisition is initialization works is that inside a scope, and you can simply open a scope anywhere within a function or a method, inside the scope you initialize an object, one of these object things, you use it, and then at the end of the scope, the destructor of the object gets called, and it automatically, in this destructor, it releases all the acquired objects. I'm actually not a... C and C++ have this. The garbage collected languages don't have this. And sorry? Okay. Right, but it's still a manual step to call it. Oh, okay, so it derives from idispose. Okay, so what our audience member here says is that there's something in C# that does this. Is similar. Very powerful. Tim. Yes, with is very good. I'd actually forgotten that because Haskell has it as well. With, it's actually usually a function, so you can do. Yeah, okay. I missed that, but anyway, RAII in C++ is really nice, and it really allows you to clean up code, and there's absolutely no, I hate doing that. Here we go. There's absolutely no chance of forgetting to delete the resources of object because the compiler does it for you, which is a real win. I'm also a very big fan of the strict static type checking that you have in the languages OCaml and Haskell, and there's a number of people here smiling, and because these are two of my little hobby horses. There's a company in the US called Jane Street Capital. They basically do a lot of very, very automated, very, very high speed, low latency trades on the stock exchange. They trade hundreds of millions of dollars per day using systems written in OCaml. They're probably one of the most high profile users of OCaml in the world. And in a paper in something called the Monad Reader, Yaron Minsky, who's basically the head of their R&D team, said one of our programming maxims is to make illegal states unrepresentable. So for the people who have done state machines in C, this is something you can't do in C. You can have, typically a state machine in C would be an enumeration with your possible states enumerated. But the problem with C is that you have a finite number of enumerated states, but C will actually say, well, okay, that's supposed to be this enumeration type, but you can put any number you like in there and suddenly you've got an illegal state. OCaml and Haskell, using particular features of OCaml and Haskell, you can actually prevent that from happening. Cannot happen. Found at compile time. Big fan of that. So I'm going to show the C example and then show how it goes in OCaml and Haskell. Type def union, for those who don't know, unions in C is basically a chunk of, well, okay, I'll step back. This union can be either a char star pointer, a pointer to a string somewhere else, an int called count, or a float called value. The size of the data T object is the size of the maximum of char star, int, and float. So it only contains so much, and it's going to have one of those three items in it in this case. The beauty of C and C-style casts is you can actually get a pointer to it, and you can actually write anything in there, and the C compiler won't stop you. And you, even ignoring that problem, if you put a char star pointer in there, you have to remember that in that object there's a char star pointer and it's not an int and it's not a float, because the C compiler will say, well, okay, if you put a char star pointer in there and you try and access it as an int, the C compiler says, I'm sure you know what you're doing, go ahead. In OCaml, and Haskell does it with exactly the same thing with slightly different syntax, you can say that the type data T has either a name of type string, a count of type int, or a val of type float. Once it has one of those things, a value of type data T will have one of those things forever, and the compiler will not let you dereference it in the wrong way. So once it's got a name and a string in there, you can't access that particular object as an int or as a float. Haskell gives you a way of constructing this. So so x will be of type data underscore t. We are constructing we're going to put a name in it here, and it's got a string. So at the time we construct object x, we say whether it's going to be a name or a count or a value. Is it value? Yes. And you give it the value that's going to stick on it. And then when you want to figure out what it is, you can do match the object with and say, well, okay, it's either going to be a name or a count or a float, and do the right thing with each type. What's even nicer is that there's a compiler flag for the compiler that says that if I don't match, if I don't have a case for all of the things that actually make up the data T object, it will throw a compile warning. And that warning can be promoted to an error. So doing that, you can do what the Jane Street Capital wants people want, and that is you make unrepresentable states, sorry, illegal states unrepresentable. For people using GNU, GCC, and G++, who uses these compilers? Who uses -W_all religiously? W_error? Sorry, W_extra? Yeah. I've always thought this is weird. W_all enable all warning messages, and then there's W_extra, which actually enables other errors that isn't included in W_all. I've never understood that, but I really like those, and in fact, there's actually others. If you read the man page for GCC and G++, there are actually other -W errors that aren't enabled by default, either with W_all or with W_extra. When I get given a piece of C or C++ code that I need to maintain, I turn on W_all, fix all the warnings, turn on W_extra, fix all the warnings, and then, for me personally, I don't ship code, so if I'm shipping source code, I don't ship source code with W_error, but when I'm compiling it, I compile with W_error, so that every time you get a warning, it's no longer a warning, it's an error message instead, and the compile stops at that point.
Why don't you ship W_error?
Because with each new version of GCC and G++, they can do two things. They can move things that were in W_error into W_all. They can add new warning messages that I've never seen before. And if I ship source code with W_error and it's shipped on a compiler that I haven't tested yet, W_error is going to go splat. If it's a warning and somebody's building it for releasing in a Linux distribution, it's just another warning. Lots of other software has warnings. It's just going to scroll past, nobody's going to care. But if you've got your package in Debian have got the build Ds, and you can actually go and see the complete package build listing, and you can actually go and say, oh, they've got a compiler that I don't have, and look, there's a warning I've never seen before. It's really nice. The other thing is that sometimes there are actually CPU-specific warnings that aren't common to all. So if you've got things that doesn't warn on x86, it might throw a warning on ARM or MIPS or something, which Debian actually does compile on. Most of the other compilers also have extra warnings that can be enabled. Most of them also have the ability to promote warnings into errors. Check the compiler documentations. Static analysis tools. I'm a really big fan of these. Maybe not the first one, because it costs a truckload of money. Covarity's Prevent has a very, very big reputation in this area. It basically does checks on code that you don't do with just a compiler. It will find things like you have, what's a good example? Threading bugs. It finds threading bugs. Compilers don't find threading bugs. It does the most amazing number of checks. One of my library packages, which I'd worked on for like 10 years, painstakingly trying to remove every single problem area, ran it under, somebody in the US ran it under Coverity for me and sent me the prevent output. It had 68 warnings. Of those, a quarter were, it broke down to basically into 4 equal categories. One was things I really didn't need to worry about. It was basically false positives. One was things in the test suite, which warnings in the test suite, I'm not, problems in the test suite, it is test code. Another one, there was basically a quarter of them, of the 68 things were real bugs. And this is a project that I had slaved over for 10 years to remove as many bugs as I could. And it found about 15, 16 real, genuine bugs. Coverity costs serious money. It's like $10,000 a year. It's at least $10,000 a year per seat per year. There's one called Goanna, interestingly developed here in Sydney. It's written in OCaml. It's also costs dollars. I don't think it's as much as Prevent. It does come with a 30-day free trial. I know some of the people who work on this project. I got given an early beta version to run over my code. I managed to crash it. I managed to find a crap load of things where it was wrong, false positives and things, but I fed a whole bunch of bugs back to them, and this was 18 months ago that I tried it. I expect it to be much better now. There's some open source ones, CPP check for C and C++. Didn't find a lot of stuff in my project, but my project was actually clean as far as Covarity's Prevent was concerned. Really interesting thing was when it actually did come under, just as an aside, when it was actually tested with Prevent, it was actually somebody offered to do it as a result of a security alert against that project, and Covarity's Prevent didn't find it. So even after it found 16 real bugs, Coverity still didn't find the one that had the security announcement had gone out against this particular project. So, you know, these tools are nowhere near as good as they could be, even though they cost a bomb and stuff. Lint for C. Lint for C is, this splint. It's a bit of a pain in the neck because you need to annotate things to say, well, okay, splint, this is really not a problem. Still worth a look. Python, I haven't looked at the Python ones. HLint, the Haskell compiler does a fantastic job of restricting the stupidities that you can do. So HLint is mainly about stylish things, whether it's good Haskell style or not, but actually quite a useful tool as well. Sparse for the Linux kernel, I forgot that one, yes. Yeah, yeah. So there's lots of these. Yeah, that's right. So there's a whole bunch of stuff.
The thing that makes sparse interesting is that they've deliberately annotated things. It's for the kernel.
Yeah.
So he's deliberately annotated things, the constructs that only exist in the kernel. So
Yep.
it's now a linter for kernel code.
Yep.
And it checks into like blocks and whether you're using, CPU specific versus some other thing. But it's all these constructs that only really exist
Yep.
in the kernel code. But it's been very successful on it.
It has.
Using user pointers and kernel pointers.
Yep. The other thing is that Covarity's Prevent was also run over the kernel around the 269 to 2612 stage, and they actually made the first report against 269 found a lot of things, and they actually fixed a lot of them by 2612 when they ran it again. But I actually think that with things like C and C++, the problem here is actually the language, and no matter how smart some of these tools are, the actual freedom that the C and C++ give you means that you've got way too much rope to hang yourself. And that's something I'm going to bring up a bit next week. Valgrind. People coding C and C++ code should be familiar with Valgrind. Actually, I'm actually coming to that. I'm almost there. It does some really good things. It finds where you've declared an automatic variable and you use it before you assign a value to it. This is just classic. It couldn't possibly be right things. Accessing arrays beyond the start or the end. Allocating memories, using memory after it's been freed or deleted, and detecting memory leaks. This is a fantastic tool.
So doesn't the compiler pick up array? Well, this is not static checks.
So the interesting thing is that you actually take your compiled code and then you do Valgrind with the program. I'm actually about to demo it. I'm going over time here, but I don't think anybody's going to. It's only the AGM.
No, bring the AGM on. I'm missing the AGM.
So people can see that?
Yeah.
Really? That's not. Okay, so that's not the one I actually wanted. And I've already compiled this, I'm pretty sure. Oh no, I haven't. And then if we do, I've called it XE just so I know which one it is. No, Valgrind. Oh, I can't find hello because I've got to look in the local directory. So, where do I put my zip? Zip this up. This is sort of the best you could possibly hope for. There's my output, and after use, the heap summary says 0 bytes and 0 blocks of heap used. Total heap, all blocks were free. There's no other errors. That's what to aim for. I've got another little piece of code. Now, those of you there who know C should probably be able to see some problems there. And here it has found use of an uninitialized value size 8. I'm running on 64-bit. So in there, if I had compiled this with -G, so it had debugging symbols, it would have actually told me the line number. Neglected to do that. Again, free at the end. Okay, so that's that. I actually came to it quite late, but I wondered, Valgrind's really great for C and C++. What about other languages? What about interpreted languages? And I came up with something that I called Valgrind Hello World. The idea is you write Hello World in a really, really simple interpreted language, simplest program you can write, Hello World, and see what happens under Valgrind. It's an interesting experiment. So here we go. How do I run this? I do. There. So there's a really simple Perl hello world, and okay, so we've got some heap still being stuff that has been allocated and not released. Now, in an executable like Perl, when it exits, when it's finished, it's done, it returns all of that heap, the operating system returns all that heap usage back to the operating system. So is that a problem, is that not? Well, maybe, maybe not. I got another one here. So let's look at Ruby. Hello, that should do it. Hello, RB. In fact, let's just have a look at it. It's the same sort of thing. It's trivially as simple. Puts hello world. That's my first Ruby code. Nah. For a program that is guaranteed to exit, so with something like Ruby or the Perl interpreter, it could be a whole pile of stuff that gets allocated once at program startup, and they know this is going to exit at some stage and the operating system is going to clean up. It doesn't get freed. I'm not going to, there are problems with this, and I'll come to those in a minute, but it's not as bad as it could be. Python, come on down. In fact, let's have a look. Definitely not my first bit of Python code, but I must say that this shocked me a little bit. Whoops! My. So somewhere deep inside Python's library, it is reading, doing an invalid read. So this address that it's reading is 224 bytes inside a block of size 470 that was freed at some previous thing. Conditional jump or move. So it's got an automatic variable. No value has ever been assigned to that, and it does if whatever, and then jumps somewhere. This shocked me, I must say. And I'm not easily shocked. Yeah. GTK, of course. So you can do this for all sorts of things. You can do this for compiled language. You can do it against libraries. So this is from the GTK tutorial. It sticks up a button that says hello world, and when you press the button, the thing prints hello world in the back and stand it out. So running it onto Valgrind. There's our button. Kill it off. Again, just like the Perl stuff, there's a whole bunch of stuff that was allocated and not freed. I'm going to say that because GTK is a library, I'm going to say that this is a problem, and I think this is unacceptable. And this is where I'm going to actually start ranting. If you as a programmer want to write code that links against GTK, and GTK is not the only one, hello OpenSSL, which is a lot worse than GTK, you'll notice that there were none of these jump on uninitialized stuff. On OpenSSL there are. At least, well, yes, and the problem, okay, so we're not going to talk about that. There's other places to get entropy, and we won't talk about that. With GTK, they're not interested in entropy. But if you write an application in C or C++, which is what you're doing when you're linking against GTK, and you want to Valgrind your application, if you do a leak check on something like that, you get a report that looks like this. Oh, I do too. Thank you. Now, if you have one memory leak, you have to find it amongst, and this is for the most simple GTK program you can write, you have to find your one memory leak amongst the 2400 that GTK introduced. If you're using a whole bunch of widgets, you've got menu bars and drawing objects and this, that, and the other, that can be 10, 20,000. If you have introduced one memory leak, you have to find your memory leak amongst all these others. Valgrind has something called suppression files where you can say, these memory leaks, I know they're there, don't worry about them. I looked at it for GTK, and I looked at the ones that the GTK developers, the suppressions file that the GTK developers provide. And I am absolutely certain that I could write a GTK program that leaks memory that with their suppressions file would say leaks nothing. I think this is unacceptable. And the other thing is, of course, there's been a bug in the Gtk bug tracker since 2001 complaining about this, and they keep on saying, not a problem.
It's nice that they've actually gone to the effort of providing you with that suppressions file rather than fixing this.
Agree completely. Now, some of what they're doing is they're allocating memory out of memory pools. Now, I think that's overkill. I don't know, it just feels, that whole GTK thing just feels really wrong to me, and it's not the only one. I know of a couple of libraries that are completely, totally Valgrind free. Most of the libraries from Ziff, which a couple of people here work on, are, I know at least the ones I use are completely Valgrind free. Some of the fixes I had to put in there myself. But you know, there are a whole bunch of libraries out there on the internet that are completely, totally Valgrind clean, so that when you write your application, you can run your application under Valgrind, and the Valgrind errors that's thrown up are your problem and not somebody else's. That's the way to make everybody's code better. We've done that. Anyway, more next month. Questions?
Not really questions per se, but I was interested about your Ruby example, same Ruby program. And 1.8, C Ruby 1.8 is pretty decent. 1.9 is worse than Python.
I was at John and Sylvia's place on the weekend, and which Python, which Ruby are you running? Is that?
I'm running three. I'm running I'm running 3 different Rubies. I'm running 1.8, 1.9, actually 4, 1.9.1, and Ruby Enterprise Edition.
Look, I wanted to bring up, that was Ruby 1.8. I wanted to do 1.9, but I've got the Ruby in Debian testing, and it wasn't anywhere near as bad. So I can quickly do.
Yeah.
Is that the secret? Nope. I might not have it installed.
Yeah, Ruby Enterprise Edition doesn't leak at all.
But I mean,
Must be fine if you're on screen.
even with things like Ruby interpreters and Python interpreters and Perl interpreters, even the apparent memory leakage problem I consider a problem, because sooner or later, in all of those languages, they will link to a piece of C code. Now, if you're writing a piece of C code which isn't a library in its own right, is only used as a plugin into Ruby, it's probably a good idea to valgrind that C code. And probably the only way to do it is to do it from the Ruby level down. And if Ruby is leaking memory, how do you tell if your piece of C plugin that goes into the Ruby leaks or not?
They use actually garbage collector, so that's why actually Ruby leaking, because it's garbage collector. It just doesn't run garbage collector at the end of the program, because there's no point in doing so.
There is C code. Well, sorry, if you write a C plugin, so if you've got to write something, there can be leaks in that C code.
Yes, there actually can be, but all C extensions using garbage collector as well. So they garbage collected, basically.
Okay, but there is actually nothing. There is yes, it may well be advised standard practice to use the garbage collector, but you can still, being C, you can just do malloc.
Yeah, you can, of course.
And if you don't do a free with that malloc, you've leaked.
Sure, but you will have this no,
and there's
just
still
because it's garbage.
Yeah, okay. There's still the possibility of in your C code this using values that are uninitialized.
Yeah, sure.
The garbage collector is not going to help you on that one. There's still value in using valgrind.
I'm not saying it's going to help you. I'm saying that valgrind will find this, because it doesn't see how it's being freed, because garbage collector does it, and it does not always does it.
Yeah.
Because there's not always time to do so.
I did say that in the case of Perl and Python and Ruby, I'm not quite sure where I stand on this thing. I know in things like GTK, it should not leak memory. Yeah, sure. Bottom line. Other questions?
So I just got another thing. I do a lot of stuff with PHP and that, and valgrind, call grind, etc. You can get some certain extensions for it, and what you can actually do is you can go through and check with PHP where all your includes are. So especially if you're coming onto a project, which I do a lot, that's a pre-built CMS or something like that, and you've got some major big memory links, or you've got it using 512 megabytes of PHP memory, and you can run it through there, and it will actually go through and show you where that's
Valgrind does a lot more than just memory leak checks, and Valgrind is a fantastic tool. And open source, GPL.
Yeah, awesome if anyone's interested in the PHP stuff, there's a great talk by Erasmus that's called Simple is Hard. And it's really good because he goes through not just, he looks at things from the Apache level, etc. Like he looks at it not just from as it's applying to PHP, you could apply it to other things. Yeah. So it's quite an interesting kind of read and talk from that perspective. But I was really keen to see what you have tonight, like what you were talking about tonight, because I think it's a real big problem. It's a huge problem, and especially the way that we've got everyday people adopting social networking, and our database is growing and growing and blah, blah, blah. And
look, I really couldn't give a damn about Facebook. Stock markets, they scare me. Aeroplanes, they scare me. The amount of software in an aeroplane, just unbelievable.
It's just, I guess, what it is. Yeah, it's the growth of everything as well, which is something that, we really haven't considered when it comes to these applications. And most of them are being built, let's face it, on scripting languages.
I'm going to cover that next week. Gus, Dita.
Rather than whisper things in your ear. Yeah. That's right. So, as you pointed out earlier, every language has had these problems. This isn't the problem we solved, even though we've got numerous languages and techniques. And you can still have memory leaks in garbage collected languages if you leave dangling references and things that you haven't removed and stuff. Less common, but you can still get them right.
I think what's happening is actually that languages are getting better. They're not where I would like them to be yet.
What I was going to say instead is you can still build a robust system on top of unreliable languages by doing things like having multiple processes and restarting when things fail and stuff like that.
And you're adding complexity.
I'm led to believe you can.
Yeah. The man in the Google T-shirt is led to believe this. Yes.
So what I'm saying
How
is
many redundancies
you can address reliability at more than the language level.
Oh, yeah, okay.
And if you take the assumption that all programs are buggy, then you have to do that. And so certainly you can do these sorts of techniques to reduce that kind of tactical errors, but you still got a strategic sort of, you need a
that works better in some situations than others. I think the situation Google is in, it probably works very, very well.
In the pacemaker case, it's quite difficult, right?
Yeah, you're not going to have redundant CPUs in a pacemaker. There's just not enough room and the power.
Switch to backup hard.
Yeah, switch to backup hard.
Interesting what you pointed out too, because Ada Lovelace, just to go back to Ada because it's a quite interesting week this week, she actually wrote from the first piece of code, first program she ever wrote, and it had nothing near 1 million lines of code and it wasn't object oriented or anything. And she wrote, my God, I am seeing this code do things that it's not supposed to do. Yeah. I'm seeing bugs, I'm seeing errors. And she saw this in X amount of lines of code. So I think it's also, we need to accept the fact that there is always going to be a level of bugs in code, and that's just it. If it was there and it was present from the beginning in 10 lines on an analytical machine, then I think it's going to be there and present on a big, huge supercomputer and on my laptop and etc. If I'm running X amount of millions of lines of code.
I'm going to talk about some stuff next month that is getting us closer to bug-free than anything we've got now. And that's basically where I'm hoping parts of software engineering go. Bob.
How does the OCaml runtime fare?
Yes, it leaks stuff that both the Haskell and the OCaml runtimes allocate stuff that doesn't get released until it exits, and then the operating system releases it. All of these languages do that. I actually know of a compiler for a high-level language that is 100% completely Valgrind clean.
Which language?
It's a language called Disciple.
Is it?
Yeah.
That just means it's slower. It's putting things unnecessarily.
More next month?
More next month.
Cool. Thank you, Erik. So Ken has arrived and is waiting next door. If you'd like to become a member, which you need to do if you want to participate in the elections tonight, you can head in and give Ken your $25 or $15 for concession. If you want to hang around for pizza afterwards, you can go and give Ken your $10. And if you don't want to do either of those, you can partake of the snacks. And just once again, it would be great if you could read over the minutes before we start the AGM so that we can save a lot of time by just taking them as read.